Welcome to STEM School. Derivation of quadratic formula by Awosile method. I just coined it Awosile method, but this method has been known. So quadratic is an equation that says ax squared plus bx plus c x to power bx to power 1 plus cx to power 0. So that's a quadratic. Quadratic is a polynomial function, and the x to power 1 is also called x to power 0 is 1. So to rewrite this, so we can write y equals ax squared plus bx plus c. You see c times 1 is c, and bx to power 1 is bx. Now, in order to start working on this, to find the solution, we have to set y equal to 0, because the line which quadratic have its solution is when y equals to 0. So if I sketch that and I drew a quadratic function there, the quadratic function here is, this is where x-axis is, and that's where y equal to 0, because if that's the c constant here, and this is y-axis, which is the line x equals to 0. So that's x equal to 0 is the y-axis, and the roots of the equations are those 2 points here. The roots obviously are 2 roots because the degree of polynomial is 2. That means it's got the highest exponent is 2. And also the one I have drawn here is a minimum. That's the minimum there. And the turning point, 1 turning point. And also the turning point is at the line of symmetry. So that's the line of symmetry where x is at the turning point. You could find that x here at the turning point and the line of symmetry, and that x is always minus b over 2a. So that's the value of x at the line of symmetry and at the turning point. So that's a quick revision on quadratic there. It will have 2 factors and 2 roots. So those are the roots, and we're going to call those roots here alpha, and that root over there is beta. So that's alpha beta for the roots. What that meant is the x value is beta. We don't know what value it is. The x value is alpha. So we don't know what values they are. So we're just calling them alpha beta. And the curve itself is called parabola. So that's a parabola. Okay. So that's interesting to start working with. Of course, this curve will have increasing function from there, from the 0 here, and gradient to positive slope. So positive slopes are increasing function, and the negative slopes are decreasing function there. So the turning point is also called the vertex. So you could, that's also called the vertex here. So vertex, or the turning point, TP, turning point. So that's a turning point there. And the turning point is minimum because it's at the minimum. You can get the maximum too. So if you sketch the maximum there, so we could do that. So that's the maximum turning point will be like that. So here will be the maximum turning point at the top. So that'll be here. So the maximum turning point there. So that's a maximum. So the vertex here, and then the turning point of maximum. Okay. Right. So the A value, the coefficient A is positive, a negative here. So minus A, that's what that is. So it's negative. The umbrella is up. It's negative there. And A is positive here because the umbrella is down. So positive A, it's positive, sunny day, and the umbrella is down. So that's one way of looking at it. Those are the two you will get in terms of the graph with solutions. You could get other ones as well, which are more like, you might get one that goes like that, where it doesn't cross the x-axis, or it might come like that, where it doesn't cross the x-axis. Those ones are complex roots. So we say complex roots. They still have roots, but they're complex roots. They're not crossing the x-axis. So that's the other type of quadratic that we can get, and they are complex roots. That's your x-axis here. Right. So let me just bring that up slightly so you can see what I'm talking about, the complex roots there. There we go. Right, so you can see that. Okay, so now let's move on. We will set y equal to 0, which means that we get ax squared plus bx plus c equal to 0. So that means that we can solve for x. That means we can make x the subject. And there are a few ways you can do it using completing the square, but this method is not using completing the square. So let's see. First, I will derive why I use those things I used, and I use the method. So the first thing I have to do is to divide through by a. So I get x squared, so let's say a over a plus bx over a plus c over a equal to 0. So that's the first thing I do. 0 over a. Now I can do that because there's equal sign. If there's no equal sign, if it's an expression, I just take a out as a factor, as a common factor. And then I will then have x squared plus b over ax plus c over a equal to 0. Now, what I need to do next is basically turn my roots. So I've got two roots here. So they've got two roots. So the first root is the x equals alpha. That's the first root, x equals alpha. So I want to work with that. I want to take x equals alpha. So let's just draw this line here. So actually I can carry in here. So x equals alpha. I want to turn that. These are roots now. So this is roots. and x equals beta. So I want to turn this root into factors. So I want to go from the root to factors. So that means I'll take alpha to the other side of the equation, or subtract alpha from both sides of this one. So I get x minus alpha equal to 0. And likewise, I do the same here. I'll subtract beta from both sides of the equation. X minus beta equal to 0. And so I've got my two factors now, which are x minus alpha, one factor, times, and then the other factor is x minus beta, all equal to 0. If I add it, in this case, if I times them, so let's times them, and they'll be equal to 0. So if I times this and expand this bit here, I would get a quadratic expression. So if I times them together, so let's just do x times x, will be x squared. X times minus beta will be minus beta x, minus alpha times x is minus alpha x, minus alpha times minus beta is plus alpha beta, all equal to 0. So I can then simplify this bit here, and I'll get x squared minus alpha plus beta, open bracket. So I've taken x out here. I've taken minus x out, so I'll put the x here, because we always write the numbers before the letters. These alpha and beta are numbers, plus alpha beta equal to 0. So this is the same quadratic equation I've got between this and this, and that's why I'll divide through by a, because I want to compare these two together. So I want to compare this quadratic here with this one here, to compare them together. Okay, so that's what I'm going to do, and in comparing those together, I'm going to get, let's use different color here. So I've got x squared, this one here, plus b over a x plus c over a, and that should be equal to x squared minus alpha plus beta x plus alpha beta. Okay, so what have I got here? Let's write it out clearly, because this has been, let's just write it here. X squared plus b over a x plus c over a will be equal to x squared minus alpha plus beta x plus alpha beta. Right, so we've got two states here. I'm going to compare these two together, and this is what I'm comparing. The coefficient of x here, this is x, and its coefficient is b over a, must be the same as this coefficient here of x here. So that is also x. So just to write it clearly, that's x. So this is alpha plus beta, and the alpha times beta here, that is also equal to c over a, the constant here. The constant here is also equal to that constant. So that's the beginning of what we're doing. So we're saying minus alpha plus beta is equal to b over a, and therefore alpha plus beta is equal to minus b over a. So this is the first thing we're going to be using. We're going to be using this bit here, and this is called roots, sum of roots. So we call that sum of roots. We're going to be using that. So we're going to be using sum, that means we're adding them together, of roots. So that's one important thing we're going to be using. And the next thing we're going to be using, so this we have to remember, the next thing we're going to be using is we're going to be using we're going to compare this one, the product of roots. So we're going to compare the alpha times beta. So there's a times here. That equals C over A. So that's this one is called product of roots, sorry. So that's product of roots. So we're going to be using that as well. So we're going to be using this. It's a second thing we're going to be using. So that's called product of roots. So let's call it. So this is number 2. So, and the reason why I'm showing you these is because I'm showing you where they come from. I took the roots from here. I call it x equals alpha, x equals beta, and I turn the x equal to alpha and beta into factors. And then now, if I multiply the factors together and expand it, I'll get this expression for quadratic, which is x squared minus sum of root x plus product of roots. So that's what quadratic is. Also, I can compare the two together. And when I compared the two, I was able to equate the coefficients of the x variables. So the x to the power of 1, x squared has 1 coefficient, so that's okay. X has these coefficients, so we'll equate them together and we derive these important formulas that we're going to be using. So that's the beginning of our journey for the definitions for deriving quadratic formula using these two beautiful equations. Right, so now we're going to use our important equations or important formulas. The first one is sum of roots equals minus b over a. So the first thing I want to do is take the average, and the average here is going to be, I'm going to divide it by 2. The average of sum of roots here, I want to take the average. So it's going to be minus b over 2a. So that's the average. That means I'm dividing it by 2. Then I'm going to use the average to basically, I'm going to use the average now as the starting point. So I'm going to say, to create my alpha, the roots that I'm looking for. So alpha will be minus b over 2a. Using the average, I'm going to take away unknown number because we're going to find the unknown number. Okay, that's my alpha. And for my beta, I'm going to say the same thing, minus b over 2a plus an unknown number. Okay, so those are my roots now. Roots. So what I'm then going to do is use this here. If I add alpha and beta, it will give me back minus b over a. You can see that. So if I add alpha to beta, if I add them together, it'll be that minus b over 2a plus minus b over 2a. It will be minus b over a. And then minus u plus u will be 0. So that will cancel out, and I'll get that back. And if I multiply them together, they should give me c over a. So that's what we're going to do now. So I'm going to do the product of rule here. I'm going to multiply alpha and beta together. So let's just draw that. Right. So I'm going to multiply alpha and beta together. Alpha times beta, so that will be minus b over 2a minus u is my alpha. And if I times it by minus b over 2a plus u, that is my beta, and that should be equal to c over a. Okay. And then what I need to do is, this remind me of something called difference of two squares. So difference of two square is dots, I call it. So that's difference of two squares. It means that if you have a letter, say n squared, and you take away another square from it, m squared, hence two squares, one square, another squares. Difference means take away, minus. You would get n minus m and n plus m. So that's what you will get. That goes for any difference of two squares. And I can see that here, if my n is minus b over 2a and my m is u, I can see there's a plus, minus, and plus of the same thing. So therefore, I'm going to have minus b over 2a. Let's just square that. So that's the square here. That's my n squared, that's my n. Minus u squared, and the u squared is going to be this, u squared. And that should be equal to c over a. So this is my u, this is my minus b over 2a. So that's u squared, n squared, and that equals c over a. So now, what I need to do then is I need to now expand this. So I get minus b times minus b is b squared over 2 squared is 4. A times a, which is a squared, minus u squared equals c over a. So what do I need to do here is I need to rearrange this equation and make u squared equals the subject. So if I move minus u squared to the other side, or add u squared to both sides, I will get, and then move c over a to the other side, or add or take away c over a from both sides, I will get b squared over 4a squared minus c over a equals u squared. So that's good. So we're getting somewhere. And so next thing I want to do is use another pen here. Next thing I want to do is now make the denominator the same denominator. That means I have to times that by 4a. I have to times that by 4a, because 4 a times a is 4a squared. So I will get b squared over 4a squared minus 4ac over 4a squared. So that's what I'll get, equals u squared. The next thing I need to do is keep them as a common denominator. So that's 4a squared, b squared minus 4ac, and that will become u squared. Now if I square root both sides, that would remove the square from this, and I'll square root these two as well. So that would be plus or minus square root b squared minus 4ac over square root of 4 is 2, square root of a squared is a, and that gives us u. So now I know what u is. I can then take my u and put it back here to find my first root. Replace my u, so I'm going to use the positive value of u only. I could use a negative value, it's still the same thing. It doesn't matter which one I use, but I have to use one of those. So I'll take the positive and put it back here. And I'll put it here as well to find my alpha and beta. So my alpha will be minus b over 2a. I'm going to replace the u with minus square root b squared minus 4ac over 2a. You can see they have the same denominator. So that will become minus b minus square root b squared minus 4ac over 2a. So that's a quadratic formula. That's one root. That's x equals to that because x equals alpha. You can see earlier we said x equals alpha. And then same thing will be for the beta. So beta, because it's a plus, so you just get a plus here. So the beta 2 will be minus b plus root b squared minus 4ac over 2a. And that is my quadratic formula. So let's write it down, because remember alpha equals x and beta equals x at the point where y equals to 0. So the x value will be minus, that's a minus by the way, b plus or minus square root b squared minus 4ac over 2a. That is our derivation of quadratic formula. Awesome. Okay, so you didn't have to use completing the square. You could, all you need to remember is the sum of root equals minus b over a, and product of root equals c over a. Make sure that the coefficient of a is 1, and then you obviously divide by a, and then you use the average. That means you divide sum plus alpha plus beta over 2, which gives minus b over 2a. And so we can use that, and we choose unknown number, which we need to, take away from the minus b over 2a and add to minus b over 2a, the average. And then that will lead us to finding this. But the thing is, we have to use difference of two squares. You don't have to, but you could multiply this out. You don't have to use difference of two squares. You could multiply that times that. Yeah, you get that squared. That times that, we just get that u, and then you get minus that times that. So you can see, and then they will cancel out, and then you get minus u times u. That would be minus u squared. So we still get those if you don't use the difference of 2 squared. But difference of 2 squared is in the specification, so it's important. Right, cheers. Okay, let's use the method I've just described to solve this problem. This is a quadratic function equation, and it's the general equation of quadratic is ax squared plus bx plus c. So when you're to solve this problem, that means that you need to make x the subject, find the value of x. So that obviously has to be equal to 0. And what we then need to do is I'm going to make these look like that. So I'm going to take away 4x from both sides and take away 3 as well. Or move the 4x to the other side, the sign will change. Move the plus 3 to the other side, it will become minus 3. So let's start. So I'm going to get 2x squared minus 4x minus 3 equal to 0. And then I'm going to divide through by a. By, in this case, I'm going to divide through by 2. So I'm going to get x squared minus 4 divided by 2 is 2x minus 3 over 2 equal to 0. We prefer that you keep the fraction, don't use decimal. Now in this case, what we're going to do now is I'm going to compare. I'm going to write my a equals 1, b equals minus 2, and c equals minus 3 over 2. So that's what we're going to use now. We're going to use this. So let's now write the sum of roots. So let alpha be, so we can say x equals alpha and x equals beta. We have 2 roots because degree of polynomial is 2. That means the highest exponent is 2, the highest power. So we'll have 2 roots and 2 factors and 1 turning point. So in order to and then what we did was, remember, we turn x minus alpha equal to 0, x minus beta equal to 0. You don't need to do that, I'm just reminding you. So now what we need to remember is alpha plus beta equals minus b over a. So that's sum of roots. So we need that. And then alpha times beta equals c over a. And in this case, I want to take the average of sum of roots, which is alpha plus beta equals minus b over 2a. So that's what we need to use, and that's what we need to remember. We need to remember that. That's what we need. And then we're going to use the alpha plus alpha times beta equals c. So alpha beta equals c over a. Now these are product of rule and sum of rule. So that's product here of roots and sum of roots. Now my alpha plus beta with minus b over 2a, so minus b over 2a will be equal to, well, b is minus 2, so that will be minus 2 into bracket, minus 2, just do that, and minus. So that's b is minus 2. And so minus 2 over, now a is 1, so that's 2 times 1 is 2. And that becomes, so b is plus 2 over 2, b is 1. right? The alpha times beta is C over A, which is minus 3. So alpha times, so that's over 2, by the way. Alpha times beta is C over A, which is minus 3 over 2. So that's alpha plus beta over 2. Okay, so the sum of this, the average sum of roots is the average sum of root is 1, and the product of root is minus 3 over 2. Right, so now let's crack on. So what we need to then do is, let me just draw this line so we don't get confused. So now what we need to do is use that in our expression. So we can say the alpha we need is, remember, the alpha is minus b over 2a minus u, and beta we need is minus b over 2a plus u. And then so what we're going to do is then multiply the alpha times beta here. So we can do this now. So alpha beta will be minus b over 2a minus, that's minus, let's just plus, it doesn't matter which way you put it, times minus b over 2a minus u is the same thing. 2 times 3 is 3 times 2. And that would be, now I know minus b over 2a is 1, because that's what it is, 1. And 1 plus or minus u, let's just say minus u, times 1 plus u is the same thing. So 1 minus u times 1 plus u, I would get, it's difference of 2 square, and obviously that equals minus 3 over 2, equals minus 3 over 2. It's difference of 2 squares, so I would get 1 squared minus u squared equals minus 3 over 2. And in this case, I'm going to take minus 3 over 2 to this side, it'll be plus, and take u squared to the other side, so I'm going to get 1 plus 3 over 2 equals u squared. Now, so that's good. Let me just come up here and draw that down. So what do I get from there? I get the reason why it's taking long is because I'm explaining. If you understand it, you just go faster. Right, so 1 over 1 plus 3 over 2 equals u squared, which means I need to make them the same denominator. So I will get 2 over 2 plus 3 over 2 equals u squared. Now that'll be, so I'll get 5 over 2 equals u squared. So add it up, numerator, keep the denominator the same. So that's how you do the fraction. Now that's u. So u will become plus or minus square root of 5 over 2. But I could make it more exciting by just multiply that by 2, and multiply that by 2, I get plus or minus square root 10 over 4. What's square root of 4? That'll be 2. So I get u equals plus or minus root 10 over 2. So that's my u. If that's my u, I can now find my alpha and beta. So my alpha, because I know what my u is now, plus or minus root 10 over 2. So my alpha will be, I know my minus b over 2a is 1. So my alpha is going to be 1 minus plus, I'm going to use a plus value of u. So minus times plus is minus. So let's just keep it there like that. So we don't need to do that. Root 10 over 2, which gives 1 minus root 10 over 2. And this one will be 1 plus, because that's a plus, and I'm using the plus value of this. So 1 plus root 10 over 2. To keep them the same denominator, remember, because it's good to keep them the same denominator as a fraction. This is 1 over 1. That will be 2 plus root 10 over 2. Likewise, that 2. So that will be 2 minus root 10 over 2. So the answers are 2 plus or minus root 10 over 2. So the x value for this expression, the x value is going to be 2 plus or minus root 10 over 2. Now let's check with a calculator to see whether we've done it correctly. So I got calculator here. I'm going to put on your screen there. And what we're going to do is basically turn on the calculator to select menu. So if you select menu, press the arrow until you get to A option. The arrow goes from 1 to 9, and 10 is called A, 11 is C, B, 12 is C. And so instead of writing 10, we wrote A. So you go, that's 1. We're going to go all the way to 10, 2, 3, 4, 5, 6, 7, 8, 9. 10 will be A. So I think that's X decimal thing going on there. 10 is A. And then, so you want equation and function. So you select that, press equals. Then you want polynomial, because we're dealing with polynomial. So you press 2. Now, this polynomial is from 2 to 4 degree of polynomial. This is 2 degree of polynomial. 3 degree of polynomial will be cubic, and 4 degree of polynomial will be quartic. So we press 2. So we got quadratic expression here. And what we're going to use is, I'm going to use that anyway. So it doesn't matter which one, I'm just going to use that. Yeah, it's the same thing. So I'll put in, the coefficient is 2, so put 2 equals. The coefficient is minus 4. So I'll put minus 4 equals, and the coefficient is minus 3 here. So put minus 3 equals. So now the next equals I get will be the roots here. So the next equals will be, okay, so you got 2 plus root 10 over 2. So that's that one here. That's good. And the next one will be 2 minus root 10 over 2. So it's that one there. So that's good. And the next thing it's going to give us, because if you sketch that graph, if you sketch this graph, let's just put a beautiful sketch here. It's not going to be perfect. Now, let's, if I want to find what that value is in real number, I'll press standard to decimal. So that will give him minus 0.05. So the coordinate is over there. Yeah, so that's the plus there. So go back to again. That's the minus. The plus will be, because it's 2 plus root, that will be somewhere here. So that'll be the alpha and beta. Now, what I also need to remember is that the intercept on the y-axis is minus 3. So I'm expecting the curve to cut through there. So it's minus 3. So it's going to go like that. Okay, it's a dodgy curve. My apology. Right. Now, so that's the curve, obviously. That's your y-axis. The equation of the y-axis is x equal to 0. And this is your x-axis. And the equation of the x-axis is y equal to 0, because it cuts the line y equal to 0. Now, so now what we need to do is the turning point is the next thing it's going to give us. The turning point. And the turning point, if I press next equals, it'll give me the turning point. So turning point, x is 1. So at the turning point, x coordinate is 1. That's what's giving me. And then the y coordinate, it's going to be the next one if I press equals. And it says it's minimum because this is minimum. The umbrella is down. It's a sunny day. Press equals again. I get -5. So this is -5 here. So -5. Remember that's -3. The intercept is -3. So that's -5. So that will be the turning point there. And that's what it's giving us. You can find the turning point without actually doing that. You could have used, to find the turning point, it is x equals -b over 2a. That's the average we've been using. -b over 2a is actually the x value for the turning point. So your -b over 2a, can you see we got 1? When we work it out, it's actually your turning point. And also it's the line of symmetry of the quadratic. It's a line of symmetry. So if you draw a straight line through that, that means where the quadratic is equally reflected. It's a line of symmetry. And so the line of symmetry is where x equals 1. So that's the line of symmetry. Line of symmetry. And right here, symmetry. So that's the line of symmetry. X equals 1. So that's beautiful. So you can get all that from even checking during the exam to quickly check what you've done to make sure everything's perfect. Your marks will be based on your workings. So, and obviously you get 1 for your answer, for getting the right answer. So it's good to know your working, to show your workings as well. Right, here's another question. Question number 2. Now we're going to use the Awosile method. It's just, you can call it anything you like, but it's this method is known. So what I'm going to do now is, obviously that looks like quadratic because the x squared first, and then x to the power 1 next, and then x to the power 0 next. So that's quadratic in that case. The highest exponent is 2, or the degree of polynomial is 2. I'm expecting 2 roots in this situation. So now let's start. I need to A is -1 right here, so I need to multiply everything by -1 because I've got equal sign here. So if I multiply everything by -1, I will get x squared minus 4x plus 3 equal to 0. So that's the first thing I will do. And then, because I'm trying to keep this as +1, so the next thing I would do is to say my A equals 1 now, and B equals -4, C equals +3. So that's good. So what I then need to do is to do my alpha plus beta over 2, which is that's the average sum of root, minus b over 2a. So that's the average sum of roots. And the value for that will be, b is -4, so I got -4 over 2 times 1 is 2, and that should give me plus 4 over 2, and that will be 2. So that is my the turning point x, the line of symmetry x equals to 2. So it's all straightforward there. So that's cool. And then the next thing I need to do is to find the alpha beta. And the alpha beta here is c. It's c over a. So that's c over a. Obviously a is 1, so that'll be 3 over 1, which is 3. So that's the alpha beta. Okay, so I've done the important thing there. So the important thing is to get to work out your average sum of roots and to work out your product of roots. So that's my product of roots. That's sum of roots, average sum of roots. Okay, so that's what we're using. Now let's just draw a line here and then start on our journey. Right, now I know what those are. So what I'm going to do is my alpha, the root, is going to be the average sum of roots, which is 2 minus u, and the beta will be average sum of roots, which is 2 plus u. And that's what we're going to do. And then we're going to do alpha times beta, which is 2 minus u root times 2 plus u, and that should be equal to 3, because alpha times beta equals c over a, which was 3. So now this is difference of 2 squared, so that gives me 2 squared minus u squared equals 3, and that's 4. Now take 3 to the other side, u squared to the other side, 4 minus 3 equals u squared, which means 1 equals u squared, which means u equals plus or minus root of 1, which is really u equals plus or minus 1. Now I only need one value here because I'm just going to put it there. So I only need one value there. Right, so my alpha is going to be 2 minus 1, which is, I'm just using the plus value of u, and that will give me 1. And the other alpha beta value would be 2 plus 1, and that will be 3. So that's sorted out there. So I found the roots. That's it. That's done. Truly. Finito. Now, so what that meant is the answer will be, x value will be 3, and the other x value equals 1. So when we sketch it, we shall get just a quick sketch. I'm expecting the value to be 1 and 3. The intercept on the y-axis, I'm using this one, by the way, so let's just use that one first. So let's use that one first because that's what we just done now. The intercept on the y-axis is plus 3, so I'm going to get 3 over there. That's my plus 3. Remember, that's y-axis, that's x-axis. The equation of the x-axis is y equal to 0. And that's y-axis. Equation of y-axis is x equal to 0 because this line here cuts x at 0. This line here cuts y at 0. Okay. Now, so sketching this, I need to find the turning point. We already know x value at the turning point. The x value at the turning point is x equals 2, because x at the turning point, the average sum of root will give you the x value at the turning point. So x value at the turning point is minus b over 2a, which what we've just done, and that came out to be 2. And it's also the line of symmetry as well. So this one is 1, 3, and that's 2 over here, 2. So if I draw a straight line down, that will be the line of symmetry where x equals to 2. So line of symmetry is x equals to 2. So that tells you everything. It's incredible. And now, what else you need to do is Now let's use calculator to show the answers of that. What we just done, we use that. We can use that too, it doesn't matter. It's going to be the same symmetry. Because it's minus here, it will be, the graph will be flipped over. But it will still have the same roots and the same line of symmetry. And the turning point, the x value of the turning point will be the same. The y will be different if it's flipped over. So what we need to do now is turn on the calculator. So let's just put that there. So turn on the calculator there. And here I would have menu. Click the menu there. Press the menu again. And then I need to go from 1 to 10 or 1 to A. So 9A instead of 10, we write A. That's hexadecimal number because of computer. And I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 10 is A. So A is equation on functions. So click equals. Select enter that. We're using polynomial. Yes, x squared is polynomial. Enter. So select 2, sorry. We go for x squared because quadratic. X squared. X cubed will be x to the power 3 and x to the power 4 will be quartic. So we're doing x squared. Select 2. We got the quadratic expression. So let's use the this one. Okay. Let's use that one because that will be, it'll be the same, but it will just give us different value of y for the turning point at the turning point. So we would have coordinate is 1. Enter. So A is 1. B is minus 4. So put minus 4 and equals. And C is plus 3. So we got 3 equals. So the first thing we give us the roots. So we can see the roots here. So press equal sign. Well, one of the roots is 3, so that's 3 there. Equals again. One of the roots is 1, and that's 1. The next one we click will give us the x value at the turning point and the line of symmetry. So enter there. We got 2. X value is 2 at the minimum. Now we're going to get a y value, which is good for us. Otherwise, you have to substitute the 2 back into the function here to get your y value, which is okay too. And just press equal sign. Y is minus 1. So it's minus 1 here. So it's down there, somewhere there. Okay. And if we draw the curve, so just go. When you're drawing the turning point, always do that. Right? And then just go there. And hopefully there. Okay, so that's the turning point, and this one is the parabola. Right, that is the intercept on the y-axis. So that's 3, the intercept. The 2 roots here, that's alpha equals 1, which is your x equals alpha. And the second one here is x equals beta equals 3. And here the turning point here, where at the turning point, so at sign 1 and minus 1, sorry 2 and minus 1 is the turning point. The line of symmetry is the x equals to 2. So increasing function we begins from here because the gradient here is 0, right? And then it goes positive, 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 positive to infinity. So that's increasing function. Increasing function when the gradient is positive, and decreasing function is when the gradient is negative. So it's decreasing function from there, and then that's 0. Okay, right, so that's the, but there's another interesting thing. We could also plot that one, I guess it's minus. So let's do that. So press AC so we can see that one. It will be exactly the same thing. The roots will be the same, but the turning point will be maximum. So here the turning point is what we call the A is positive, The umbrella is down. It's on a positive day. Everyone is happy. But if A is negative, well, we're expecting to have exactly the same thing, but it will be, instead of -1, it will be, we can work out the X value will be the same, but the Y value will be different. So let's look at that. Let's do that here. So to carry on, just press AC on your calculator. You get the expression back again. And let's put A is -1 this time. So you press -1. That's the A coefficient. B is 4. Okay. And C is -3. Enter. Now, if we press, we still get the same roots. So, okay, 3 for that one. 1 for that, so the same root. Now the turning point, X value of the turning point should still be 2. There you go, 2. And then the Y value will be different. It won't be -1, obviously. It will be up here somewhere. So it will be +1. So, and then it will cut the thing at -3. So it wouldn't cut at 3, sorry, it will cut at -3. So it will be +1. So let's say that was +1 there. So let's assume that's +1. So I'm going to put it there. Let's slam it there. Okay, that's +1. And it's -3 here somewhere. Let's assume that's -3. Okay. And then the turning point will just go like that. So the turning point will be there, coming down there. Okay, right. Okay, so, and here we go, there and there. Right, so that'll be the turning point. So that's for the, again, parabola, and the equation for the green one is -x². Right, actually let me write it where you can see. So the equation for that will be -x² plus 4x minus 3. And the red one, obviously the equation is, so let's write the equation, x² minus 4x minus 3, and let's say y equals that, and we say here y equals that. So pretty exciting. Okay.